So I currently have the Hello World exorcism pulled up here. I can show you real quick. Um, and this is just the very first one for the Haskell track, so signed up for that this morning. I will be doing this one and probably the first one after it, the first real one, just because I think since I chose the mentored step, I'm going to have to wait until I get feedback to continue on, but that's okay because I'm really just wanting to do this kind of like as a refresher free exercise before I dive into learning some more, and then I will continue on with the Learn You a Haskell for Great Good Chapter 2, focusing on types and type classes after that. So yeah, I guess I'll just get started real quick. So this one, it's telling me it's just like the basic hello world, gotta pull it down. Already did, cool. Looks like it already gave us the framework here, so we have the module hello world, where hello string, hello error, you need to implement this function. Okay, so it looks here we need to implement the hello function, and let's run the tests first, so that's going to make sure that we know what we need to run. Okay, let's install stack here. It looks like we need that. Just sipping on some coffee while I'm waiting. Alright, cool. Let's try that again now. Interesting. Not sure why that's happening. Maybe I won't be doing this right now. That's weird that I have to do stack upgrade even though I literally just installed it, but okay. So let's try that. Also, I noticed last time my voice audio was a little bit low compared to the music, so I kind of messed with those settings. Hopefully it's a little better today. I also noticed that there was like a lot of mic pop and stuff like that, so just gonna try and fix that over time. Definitely new streamer things, not really sure what to do. Yeah, no, I have another mic as well that I might set up afterwards. Hopefully it has a better quality than this headset mic, which I just kind of wear for gaming when I do that. Alright, while it's thinking, I'll look forward a little bit. So running the tests, I will run stack tests after this is all done. Or, I ran it, and I'm just waiting for it to update, it looks like, or installing it. Okay. Maybe I can look at the tests while we're waiting, though, to get a better idea. So it looks like I'm just returning the string here, right? Let's run it real quick. Huh, what in the world? Let me kill this and start a new one. Oh, man, gotta love this. Literally no feedback either. Fantastic. This is one of the problems with me trying to develop in the Windows Linux subsystem instead of just doing it on Windows, but I don't know. For most software development, Windows just sucks. But I obviously want a Windows machine for gaming and things like that. And I'm too lazy to partition and create a, Linux distro on one side. Maybe I will do that at some point, though. Thought I had this all set up before turning on the stream, but I guess not. Guess while I'm waiting for this, I will start reading about types and type classes. Well, it says it installed it. Let's see if it actually did. Claimed to have earlier. Alright, so something to note for the type systems. Haskell has a static type system. The type of every expression is known at compile time, and that leads to safer code. If we write a program where you try to divide a Boolean type by some number, it won't even compile. That's good because it's better to catch such errors at compile time instead of having a program crash. True. Everything in Haskell has a type, so the compiler can reason quite a lot about your program before compiling it. I really do enjoy that, especially seeing that I work with JavaScript for the most part in my day job. You know, having a static type system such as this, and even to some extent Rust, is so nice, where it just like tells you that you wrote something that cannot work. Alright, looks like since I made the change beforehand, it passes. Cool. Oops. Hopefully this runs a lot faster now. Cool. I'm just going to set this back to what it was beforehand to make sure, so we can see what it looks like when it fails the test. Alright, hello, uncaught exception, error call, you need to implement this function. Alright, yeah, that makes sense. So let's change it back. Run our test one more time. See that we pass, and then we will submit this to be done with it. Okay, hold on. Do we just submit the hello world? I'm assuming so. Let's just do that. So it's going to be source. Exorcism submit source hello world.hs. Excuse me. What? Hold on. Alright. So we have it there. This shouldn't exist because we just created our bash profile. Why is that in there 3 times? Alright, so we should be able to source it again, and now... Okay. Let's make sure that that still works now. No, what the fuck? Why is my bash profile disappearing? It's not. Okay, hold on. did. Okay. Okay. Okay, there we go. So now not that. Bash RC. There we go. So is there anything for path in here already? No, doesn't look like it. Cool. Alright, so that was a fun little 20-minute detour. Cool. Well, that's alright. That kind of stuff happens, doesn't it? Alright, so now let's actually try and submit it. So we're going to do exercism submit source hello world.hs. Alright, cool. Let's see here. So if I hit refresh on here, exercise has been submitted successfully, if you want to see. Boom. Cool. And then we can complete it. Sure, why not? Someone can totally comment on my hello world, because why not? Alright, so this is the next one, it looks like. Looks like it's a leap year type thing, so I'll just pull that over here and I will copy it. I'll pull that down. Because I'm lazy, I'm just gonna open up a new, oops. New window here. Got our new terminal. Our source and our tests, so we can have both those open. I'm gonna try and look a little bit more at the test probably than usual, just so I can get used to reading them. I obviously haven't written any tests in Haskell because I'm still very, very, very new to it, but I figure it's a good thing to expose myself to as early as possible. So, given a year, report if it's a leap year. The tricky thing here is that leap year in the Gregorian calendar occurs on every year that is evenly divisible by 4, except every year that is evenly divisible by 100, unless the year is also evenly divisible by 400. For example, 1997 is not a leap year, but 1996 is. 1900 is not a leap year, but 2000 is. Notes, though our exercise adopts some very simple rules, there is more to learn. For a delightful form and explanation on the whole year, leap year phenomenon, there's the YouTube video. Cool, don't terribly care for that. To complete this exercise, you need to implement the function isLeapYear that takes a year and determines whether it is a leap year. So let's just run the tests real quick, let it do its thing. We should see failures, cool. Or at least one failure. I don't know, is there only one test? It seems like there's multiple tests, right? So that's a little annoying. I wonder if there's a better... So it's gonna be the 2015, which is that first one. I wonder if there's a way to like execute all tests regardless of failures. Put that in my notes over here. Questions. Way to use stack test. Where it runs all tests regardless of others passing. The reason being is that I just sometimes like to see multiple errors at once, because it sometimes is helpful, or multiple failures I should say. Alright, so we have our signature here, is leap year, and it takes an integer and returns a bool, and we will be getting that as the value year, and then we just need to do that logic. So I've seen if else already. I'm wondering if there's a better way to do it though. So leap year is every 4 years. That would be the most basic one, right? So if year remainder 4 equals 0, then true, else false, right? Like that's like a very basic one, I think. Redundant if. Okay, so that's just saying that we could do year rem 4, which makes sense here, right? I don't know if that would even pass the first one or not. Okay, so it passes the first 4, so that's like the common case, right? So 2015, 1970, 96, and 1960 all works. But the next one, 2100, which is divisible by 4, but it looks like it is not divisible by 100, right? So I think we can just do our and here, right? So if it's that, and your remainder 100 is not equal to 0, right? I think that one will pass that one then, 2100. Yep, so we got past 2100 and 1900 with that logic, but this last one, unless the year is also evenly divisible by 400. So I think we're going to actually have this, right? So, and your remainder 400 is evenly divisible. Let's try that. Alright, so now we failed this one again, so it's not divisible by 100. Alright, so on every year that is evenly divisible by 4, so that, oops, that is that first part here, right? Year, except okay, so I see it now. I think okay, my logic's off a little bit, but that's alright. Let's try that. I think that's right. Okay, yeah. I think I was just doing the check on the 100 again. I was reading that wrong, essentially. Because it's the evenly divisible by 4, except every 100 years is one chunk, if you will, and then this was independent. I was actually reading the unless to also include that it was this and that for whatever reason, but it was unless all of this, so this is negated essentially if this is true. Cool. So I'm curious, I know there's remainder and I know there's mod. And I think they return the same, or it'd be true for this as well, right? So what is the difference between remainder and mod? In Haskell? Like, why would I use one? Alright, so we got this one. What exactly is the difference between mod and rem and Haskell? They both seem to give the same result. Yep, so we got mod 2.3, rem 2.3, all that good stuff. Okay, so they're not the same when the second argument is negative. Remainder is integer, mod is integer modulus, so I think I would use remainder here instead of modulus. Just makes more sense. I think this is the cleanest version I could do. Like, I don't know if there's anything that I could do cleaner for this, so I'm gonna go ahead and just have this as my result here. Yeah. So let's see here. So it's working, and now we can just submit it, right? So submit, source, leap year. Cool. Alright, so it says, well done on submitting your iteration. A mentor will check out your work and leave a comment here on your solution soon. There are currently 12 solutions ahead of this in the Haskell queue and 0 ahead in the Leap queue. Cool, so the median waiting time is about 6 hours, so maybe tonight I will get that back. That's kind of cool. In the meantime, why not try a different exercise on the Haskell track or explore other exercism tracks? And it looks like I can put like a comment in here, which is kind of cool, so maybe I can ask them as well just to double check my logic here on the rem versus mod. But I think I'll leave it as is for right now. So let's go look at the Haskell track and see if there's anything else we can do. Okay, so there are some extra exercises. Maybe I will come back and just do some of these extra exercises after I do my types and type classes a little bit. Looks like I have an easy one with strings. And yeah, I could probably jump into that one soon. Cool. So we will go back to our types and type classes and leave this one be. So we are back in our kind of like learning Haskell for greater good repo here. Let me just exit this and relaunch it. And we'll hop in the GHCI. And then how do I change that again? That's something else that I need to remember. So that way I don't necessarily see prelude over and over again. Okay, so it's set prompt. And then I can do whatever I want here. I'll do that just so I'm similar to the book. Alright, so back over here, and again for everyone, this is Types and Type Classes, and it's part of the Learn New Haskell online book. It is free, so if you are curious, you can jump in and check it out as well along with me. But this is basically what I'm just kind of following through, if you will, to learn Haskell. I'll update this title as well, so I have it working on some Haskell okay. Types and type classes. Alright. Now we're ready. Alright, so previously we mentioned that Haskell has a static type system. The type of every expression is known at compile time, which leads to safer code. If you write a program where you try to divide a Boolean type with some number, it won't even compile. That's good because it's better to catch such errors at compile time instead of having your program crash. Everything in Haskell has a type, so the compiler can reason quite a lot about your program before compiling it. Unlike Java or Pascal, Haskell has type inference. If we write a number, we don't have to tell Haskell it's a number. It can infer that on its own. So we don't have to explicitly write out the types of our functions and expressions to get things done. We covered some of the basics of Haskell with only a very superficial glance at types. However, understanding the type system is a very important part of learning Haskell. A type is a kind of label that every expression has. It tells us in which category of things that expressions fit. The expression true is a Boolean, hello is a string, etc. Next we'll use the GHCI to examine the types of some expressions. We'll do that by using the :t command, which followed by any valid expression tells us its type. Cool. So if we do TA, okay, so it tells us that it's a character. T true, Boolean, cool. I think this one will give us a character array, right? Yep. Or character list, sorry, list. Let's get the type of this tuple here, which should be Boolean character, right? Yep. And then this should give us a type of Boolean as well. Sweet. So here we see that doing :t on an expression prints out the expression followed by : and its type. : is read as has type of, okay? Explicit types are always denoted with the first letter in capital case. A, as it would seem, has a type of char. It's not hard to conclude that it stands for character. True is of bool. But what is this? Examining the type of hello yields square bracket char. Square brackets denote a list, yep. So we read that as being a list of characters. Unlike lists, each tuple length has its own type, so the expression true A has the type of bool char, whereas an expression such as ABC would have the type char for is equivalent to 5 will always return false, so its type is bool. Functions also have types. When writing our own functions, we can choose to give them an explicit type declaration. This is generally considered to be good practice, except when writing very short functions. From here on, we'll be giving all the functions that we make type declarations. Remember the list comprehension we made previously that filters a string so that only caps remain? Here's what it would look like with a type declaration. Okay, so it's actually this one, and I believe this is the type of declaration right here. I'm going to type it out though, just so I have a little bit more practice with that. So we're going to remove uppercase, has type of, and it takes a character list and returns a character list. So there we go, that is our type there, type declaration for that function. Let's see here. I'm actually going to create a new file for this. I guess that's good enough. Types.hs? Sure. I don't think that's going to conflict with anything, hopefully, but who knows. Alright, so we have another example. But how do we write out the type of a function that takes several parameters? Here's a simple function that takes 3 integers and adds them together. And it is called add3. And it has the type of int. Cool. So here we have add3, and it will take x, y, and z. And it equals x plus y plus z. Cool. And if we load up this, we should be able to do the add3. Cool. Wait, that doesn't make any sense. That's because I did z plus y plus... See, this is why we test. There we go. Now we have the correct 6 instead of 8. The incorrect 8. The parameters are separated with the arrow, and there's no special distinction between the parameters and the return type. The return type is the last item in the declaration, and the parameters are the first 3. Later on, we'll see why they're all just separated with arrow instead of having some more explicit distinction between the return type and the parameters, like int, arrow, int, or something. If you want to give your function a type declaration but are unsure as to what it should be, you can always just write the function without it and then check with the :t. Functions are expression 2, so :t works on them without a problem. Here's an overview of some common types. So int stands for integer. It's used for whole numbers. 7 can be an int, but 7.2 cannot. Int is bounded, which means that it has a minimum and maximum value, usually on 32-bit machines. The max possible int is big number, and then, yeah, so bounded makes sense. Integer stands for also integer. The main difference is that it's not bounded, so it can be used to represent really, really big numbers, and I mean really big. Int, however, is more efficient. Okay, so there's int and integer. For example, though, if we wanted to do factorial, which is going to give us some big numbers, we'd use integer. So factorial has the type of integer. And it's going to take in, and it's going to be the product of 1 to n. Wow, that is so clean. So if we load this up, and then do factorial of 50, which would crash in most systems, it gives us a huge number. And that wouldn't work, I don't think, if we did int, right? So if we did int, reload, and then try that again, we have wraparound, as we can see, and that is absolutely not correct and not what we were looking for. Alright, cool. We also have float, which is a real floating point with single precision. So they have an example of a circumference function, which has type of float. And it will take r equals 2 times pi r. And let's do, in their example, circumference 4.0, cool. And I think if we do this, yeah, okay, so we'll convert just an integer under the hood to 4.0 for this to work. Double is a real floating point with double the precision, so if we do that with, we can do the same thing. We'll use our apostrophe to rename this, and then we will do double instead. We got a lot more precision now. Cool. Bool is the Boolean type, which we've seen. We only have 2 values for that, true and false. And char represents character. It's denoted by a single quotes. A list of characters is a string. Tuples are type, but they are dependent on their length as well as the types of their components, so there's theoretically an infinite number of tuple types, which is too many to cover in this tutorial. Note that the empty tuple, which I think Vivax mentioned last time he was in here, was open close parens. It's also a type which can only have a single value, open close. So what happens if I do the type of that? What does it tell me? The type is that. Sweet. Yep, cool. We have type variables as well. Okay, so what do you think is the type of the head function? Because head takes a list of any type and returns the first element. So what could it be? Let's check. Alright, so we will use our handy dandy type check on head. And head has the type of list of A and returns A, or has a return value of A. So it says, what is this A? Is it a type? Remember that we previously stated that types are written in capital case, so it can't exactly be a type. Because it's not in capital case, it's actually a type variable. That means that A can be of any type. This is much like generics in other languages, only in Haskell it's much more powerful because it allows us to easily write very general functions if they don't use any specific behavior of the types in them. Functions that have type variables are called polymorphic functions. The type declaration of head states that it takes a list of any type and returns one element of that type. Although type variables can have names longer than one character, we usually give them names A, B, C, D. Remember first, or FST, it returns the first component of a pair. Let's examine its type. Alright, let's check that out. Alright, so it's saying it's type A, B, and it returns A. Okay. That's what we can use first on a pair that contains any two types. Note that just because A and B are different type variables, it doesn't mean that they have to be different types. It just states that the first two component types and the return value type are the same. Or sorry, the first component's type and the return value type are the same. Typeclasses 101. Right, a type class is a sort of interface that defines some behavior. If a type is a part of a type class, that means that it supports and implements the behavior the type class describes. A lot of people coming from object-oriented programming get confused by type classes because they think they are like classes in object-oriented. Yeah, that sounds, again, they're not. You can think of them kind of as a Java interface, only better, yeah. What's the type signature of the double equals function? Let's check it out. Note the equality operator is a function, so are plus, star, minus, slash, and pretty much all operators. If a function is comprised of only special characters, it's considered an infix function by default. If we want to examine its type, pass it to another function or call it as a prefix function. We have to surround it in parentheses. So I guess they're just saying, like, if I wanted to do the type of plus, I'd have to do that. Let's get this one back up at the lowest here. Interesting, we see a new thing here. It's the fat arrow symbol, I guess I'll call it. Everything before the fat arrow symbol is called a class constraint. So EQA, and I guess in the plus num a would also be that. We can read the previous type declaration like this. The equality function takes any two values that are of the same type and returns a bool. Okay. These two types, or the type of those two values, must be a member of the EQ class. So that's the class constraint. Okay. The EQ type class provides an interface for testing for equality. Any type where it makes sense to test for equality between two values of that type should be a member of the EQ class. All standard Haskell types except for IO, the type for dealing with input and output, and functions are part of that type class. The lm function has a type of EQA. Alright, well, actually I'll just put that here because it should show up, right? Yeah, okay, so it has this foldable, which isn't mentioned in here, but there's this EQA, a T, a bool. So it's not quite the same here as what I got, what's showing in the book. That's a little unfortunate, because it uses equality over a list to check whether some value we're looking for is in it. So some basic type classes. We have the EQ type class. It's used for types that support equality testing. The functions its members implement are equals and not equals. So if there's an equals class constraint for a type variable, or an EQ, class constraint for a type variable in a function, it uses equals or not equals somewhere inside its definition. All the types we mentioned previously except for functions are part of EQ, so they can be tested for equality. Alright, yeah, that makes sense, 'cause we've done that a lot, where we just do like random stuff like... Oops, sorry, lead 0 here. So that shows that we have that, and it is part of the EQ type class. Ord is for types that have an ordering. So it gives an example of, checking this, so we have ord A, and its type signature is a bool. All the types we covered so far. Wait, so that means we should be able to do like this, right? Yeah, cool. Of course, I knew that, but just it's fun to see. All the types we covered so far, except for functions, are part of ORD. ORD covers all the standard comparing functions, such as greater than, less than, greater than equal to, less than equal to. The compare function takes two ORD members of the same type and returns an ordering. Ordering is a type that can be greater than, less than, or equal, or GT, LT, EQ, meaning greater than, less than, and equal respectively. To be a member of ORD, a type must first have membership in the prestigious and exclusive EQ club. So we can do interesting. So we can do like 5 is greater than 4, but we can also do 5 compare 4, and that should give us that GT or greater than comparison back. Cool. There's also an example of like comparing two strings. And I'm assuming it's literally just because of the A and Z, right? Comparison to strings is weird to me. I'm sure there's some place where people actually use that, but I can't immediately think of something that I'd ever want to use that for. Alright, members of show can be presented as strings. All types covered so far except for functions are part of show, so pretty much functions are its own thing that doesn't appear to be part of a lot of these type classes. The most used function that deals with the show type class is show. So capital S show is the type class, lowercase s show is the function. It takes a value whose type is a member of show and presents it to us as a string. Interesting. So if we just do 3, we get 3, but if we do show 3, it gives us 3 as a string. Same with any sort of floating point value, or fractional, I guess I should say. And then even with our boolean, it gives us that back as a string. That's pretty neat. Read is sort of the opposite type class of show. The read function takes a string and returns the type, which is a member of read. Okay, so we're able to do like read true, or false. Read 5 plus 4. But we can't just do that, right? Interesting that you can't just do it by itself. I'm not sure what's up with that. Ooh, this one's kind of cool though, the example where we can actually have a list like this. And then, cool. Oh hey, I got ahead of myself. So far so good. Again, all types covered so far are in this type class, but what happens if we try to do just read 4? Showing the error that we got here. Well, actually, it's showing more of an error. It's saying ambiguous type variable a in the constraint. Read a arises from the use of read. So essentially, it sounds like we just don't have enough context to figure out what to do with that value. So we should be able to do like not show true. No. Maybe like this. Nope. Okay, so I lied there. I thought that would have been enough context, but I guess not. What GHCI is telling us here is that it doesn't know what we want in return. Notice that the previous use of read, or uses of read, we did something with the result afterwards. That way, GHCI could infer what kind of result we wanted out of our read. If we use it as a boolean, it knew that it had to return a bool. But now it knows we want some type that is part of the read class. It just doesn't know which one. Let's take a look at the type signature of read. Sure. So read A, string to A. Okay. See, it returns a type that is part of read, but if we don't try to use it in some way later, it has no way of knowing which type. That's why we can use explicit type annotations, okay? Explicit type annotations. Type annotations are a way of explicitly saying what the type of an expression should be. We do that by adding the type of, or colon at the end of the expression and specifying a type. So, are we able to do this then? Oh, sorry, bool. Okay, so that works. It looks like we can also do like read 5 integer, I'm sure as well. What if we do float? Yeah, cool. Interesting. Then we can do like yep. Oops, it'd help if I type that correctly. And if we do this as a float, it should give us a cool bunch of floats back. Yep. Alright, so most expressions are such that the compiler can infer what their type is by itself. But sometimes the compiler doesn't know whether to return a value of type int or float for an expression like read 5. To see what the type is, Haskell would have to actually evaluate read 5, but since Haskell is a statically typed language, it has to know all the types before the code is compiled, or in the case of GHCI, which is where we're working at right now, evaluated. So we have to tell Haskell, hey, this expression should have this type in case you didn't know. Enum, so we have another type class here of enum. Members are sequentially ordered types. They can be enumerated. The main advantage of the enum type class is that we can use its types in list ranges. They also have defined successors and predecessors, so you can use that suck and pred function. Types in this class are the empty tuple, bool, char, ordering, int, integer, float, and double. So as we've seen before, we can obviously do this kind of range. We can also do, it looks like, less than to greater than, and we should get interesting. Not in scope. Oh, do I need to put a space? There we go. Less than equal to and greater than. Sorry, just coughed for a second. Didn't want to cough into the mic. That means we should be able to do also like the successor for greater than, which should give us equal. No. Why can't we do that? And we can do it for this one. Do it for this. Oh, it's because I did successor. That would make sense. So I can't get that successor, but I can do this one. And I can do predecessor for greater than. Okay, that makes sense. Cool, so bounded members have an upper and lower bound, so we have a min bound of integer, it looks like. That's what we were talking about earlier, where we have that, and it will give us this value, this negative here. We also have a max bound. Cool. We have that for character as well. Boolean, I guess, right? We'd have true, and then min bound would be false, right? Cool. Alright. Min-bound and max-bound are interesting because they have a type of bounded AA. So let's look at that real quick. Yep. In a sense, they are polymorphic constants. All tuples are also part of bounded if the components are also in it. So if we have bounded components of the tuple, then we can obviously get the bounding of that tuple. That makes sense. The example in here is bool int char. That should give us all of those values back that we were seeing earlier as part of the tuple. Alright, so num is a numeric type class. Its members have the property of being able to act like numbers. Let's examine the type of a number. Here we go. Type of 20. Alright, so we got num p. It appears that whole numbers are also polymorphic constants. It's kind of a weird term. I need to kind of stew on that a little bit more to get really what they're meaning by defining something as a polymorphic constant. They can act like any type that's a member of the num type class. So okay. Those are types that are also. Oh, sorry. Those are types that are in the num type class. If we examine the type of star, we'll see that it accepts all numbers. Yeah, I think we saw that with the plus operator as well, right? Yeah. Cool. So it takes two numbers of the same type and returns a number of that type. That's why if we do this expression, it will actually return a type error because we are not using the same type, right? So we do 5 int times 6 integer. Could not match expected type int with actual type integer in the second argument. Okay. But if we did this, it would work, I think. Yeah, it would work because it would turn that 5 into an integer. Or because it can act like it, not turn it into, I guess. To join num, a type must already be friends with show and EQ. Okay, so it sounds like there's constraints on type classes where it's like if you want to be part of this type class, you also have to be part of these other type classes. In the case of num, you must also have show and EQ. Integral is also a numeric type class. Num includes all numbers, including real numbers and integral numbers. Integral includes only integral whole numbers. In this type class are int and integer. Floating includes only floating point numbers, so float and double. Alright, that makes sense. Let's see the type of. Oh, sorry, that makes sense though. Very useful function for dealing with numbers is from integral as a type declaration. Let's see what the type declaration is. Integral a num b a to b. Or maybe not 2, but a arrow b. From its type signature, we can see that it takes an integral number and turns it into a more general number. That's useful because when you want integral and floating point types to work together nicely. For instance, the length function has a type declaration of length, and it takes a list of a and returns integer. Let's just do this real quick to see that. Cool. Instead of having a more general type of num b length a b, I think that there's, for historical reasons or something, although in my opinion it's pretty stupid anyways, If we try to get the length of a list and then add it to 3.2, or 3.2, we'll get an error because we tried to add together an int and a floating point number. Right? So like let's let list equals 110, length of list gives us 10, but we can't do length list plus 3.2, right? That's what he's saying. Okay, so we'll get the error there, but we can do from integral length list plus 3.2. That does work. Just not sure how that's really working though. Because it has this, right? So we have integral a num b. Is this where they were talking about how it's like a polymorphic constant, so it doesn't really matter? Maybe? I guess that could make some sense. Alright, well looks like that is the end of that section at least. Next section is going to be the syntax and functions. It looks a little bit longer. So let me look at this thing. Let me look at this acronym. Alright, convert a phrase to its acronym. Techies love their TLA, three-letter acronyms. Help generate some jargon by writing a program that converts a long name like portable network graphics to its acronym PNG. Okay. This exercise works with textual data. For historical reasons, Haskell's string type is synonymous with a list of characters. For more efficient handling of textual data, the text type can be used. As an optional extension to this exercise, you can read about string types in Haskell, add text to your list of dependencies in package.yaml, import data.txt in the following way. You can now write e.g. abbreviate text and refer to data.txt combinators as e.g. t.filter, look up the documentation for data.txt. Okay, that seems like something a little bit more than I want to do right now, so I'll try and do a little bit more of a generic version, if you will. This one's going to be a lot of Google foo though, because I'm not really sure. So we're going to do Ruby on Rails, ROR, HTML, first in, first out, okay. Take string and string. So I guess the first thing I want to do is probably split the words, right? So how would I do that in Haskell? So if we want to split a string on white space in Haskell, it looks like there is a function called words. Let's see what that is, or what that looks like. So if we do words, hello world, that gives us hello and world. So it does have abbreviations, or it has punctuation, I guess, right? And looking at the tests that we have, it looks like this will work for just fine for like this portable networks, network graphics, right? So if I do not words but words, this, it should give us what we want. Interesting here. So there are some where it's like lowercase words. There's some where we want to have this one's going to be interesting. This hypertext markup language, HTML, because we need to get this T inside of here, right? So now, okay, and then this first in, first out. This is one that we don't necessarily want to have that comma in the punctuation, right? I don't really care about that. How do we remove so we can filter out? Let's see if there's a built-in function before I build one. Haskell remove. Alright, so let's build a function then, I guess, where we're going to strip letters. It's going to take a string, it's going to take another string, and it's going to return a string. The first string is going to be the input itself. And then the second one is going to be the chars. And then we're going to do something like that. What's this gonna tell me? Use not lm. Oh. Well, shoot, yeah, I'll use that. Oh, and then use infix. Cool. It suggests me to not use infix, and then it tells me, nah, you should probably use infix. That's cool. Let's try that. So if we load up acronyms, let's strip characters. What were we doing? We're doing last in, first out, and we want to get rid of commas, right? Cool. And if we want to get rid of extra stuff, that's cool as well. So we can make our own little like definition here, I think, of invalid characters or something like that. And that's going to be a string. And we can just do like comma, underscore. Actually, hold on, let me check something real quick. We'll do this, but what was it? Like A, Z. Okay, yeah, no, not good enough. We'll do like a comma and underscore dot question mark exclamation mark even. Colon, semicolon. I think that works, right? So now we could do this, and then we could even use our invalid chars here. Cool. What's another one? Oh, yeah, that seems good as well. So if we wanted to do this one, what should we be able to do? And then if we do words on that, right? Cool. Something I'm seeing here though, this looks a lot more fancy, is filter. I don't know if that's, maybe I can rewrite it using this. So what if I do filter invalid characters for this? Nope. Okay, so it's like if it's an element of that, I guess, right? I mean, it's fine. What I have right now is technically okay. Cool. What if we have parts, which will take a string and return an array of strings. And then we do words of strip characters, invalid, or sorry, excess this invalid characters. So now if we load this up and we do parts of this, it should give us that. Cool. Parts of this. Okay. Okay. Interesting. Maybe I need to actually, instead of strip, do I replace? Maybe that's what I do. Google. And I'll rewrite this whole thing at a later time using the text package as well. I think that might be a good thing to do tomorrow to kind of get warmed up. So I mean, this is one way to do it, right? So it's like, if, what the heck, no, give me this. So, if, then, else, s, I think that works technically. Let's see if that does weird stuff with this. Sorry, I did that wrong here. There we go. Okay. Okay. Yep. 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 Okay. All right. Actually, I changed that, so it's gonna actually be like replace. A super long name. Why not, right? Okay. So now we can grab the parts, and now we need to actually create the abbreviation, I think. So I mean the dumb version the simple version, right, is to just take the first letter of each one and make sure it's capitalized. Is there a 2 upper or anything like that? Nope. Or, sorry. Nope. Google is showing there is, but, you know. Why am I not getting a 2 upper? How do I import stiff? Should just be import right? Okay. That makes sense. So let's see, the dumb version here would be to give an excess, we return eggs. And we filter yes, we do all of them, but it's wait, hold on, okay. Maybe it's not list comprehension, it is parts excess. Maybe it is this, so it's so if we do this, let's abbreviate this first one. So we're just doing this portable network graphics. Cool. Ruby on Rails, though, will not be what we expect. Because it's going to give us a lowercase o. So we're actually going to want to do to upper. Okay. The next one, though, HTML, also won't work, right? It's going to give us HML. We need HTML. But first in, first out should work. Cool. This one will work. This one kind of works. Oh wait, yeah, no, this one does work. This one should work. Yep. This one should work. As are these last two should work as well. Yep. So really it's just the HTML at this point, right? Yeah. So, but the problem, not the problem, but this one and this GNU will kind of fight against each other. I can't just let's see here. Alright, this is kind of dumb, but it's going to be like it's going to take a string, it's going to return a string. Let's actually move this down. Okay. So let me think here. So I want to take each letter, right? Okay, so okay, so if we want to load that up, then yep, so we get hypertext. This should give us all of them back. Yep. Most of these other ones, though, it's just like first, right? So we're going to do get capitals for x. If Alright, let's see what map has for me, if it has anything for me at all. What if I do this?
Yo, step back and watch the young MCs deliver words. Some real complex rhymes and some shit you never heard. And niggas have the nerve to say my shit is really whack. All you nice, please come battle me and see me over wax. It's the fact my lines attract people from the golden era. Lyricism up to par, I'm sick of this and salmonella. Oh, come on now, who better than the GELS? I'm the best rapper out since the NAS. Yes, I'm pretty confident on what I'm delivering. You quivering while you hating, man. Don't need to be belligerent. The music is just music, but the music is your income. You ain't make $1 yet, then you gonna need a lump sum of cash to clear out all of the trash. You suckers gon' need a body bag when I split you in half, cause word is born. You niggas need to sit back and relax and stay out of my way. When I'm about to attack, it's like that. It's like that. Yeah, it's like that. It's like that. Yo, check it, yo. One time for the niggas that reside on Webster Ave. I represent y'all to the fullest, so don't worry, I got your back. I be sparking madness, and when I'm rhyming on the mic, I be quick to kill the game with a pen and some graphite. Hip-hop's best secret, though I'm not your savior. People be expecting shit, but couldn't do me a favor. But enough of that, let's get back into the subject.
Well, I'm coming up on my 2 hours here, so I'll probably call it quits in a second. I'll think about this and I might tackle it as like the first thing I kind of work on tomorrow morning. think that would work out pretty well. So I will catch y'all later. Thanks for anyone who's watching. See you next time.